Hello everyone, it's Ali from Swiss course and this is the ultimate challenge number 1 in our trigonometric relationship series for intermediate learners. Remember, our ultimate challenge exercises are designed to be a bit more difficult than the standard ones, so I encourage you to tackle this challenge after you've watched the main course videos and completed the exercise videos. Here is the first identity to prove, and to deal with this, I'll use the algebraic identity for the sum of cubes first. So the left side of my equation can be written as sine squares alpha cube plus cosine squares alpha cube, which is actually a cube plus b cube. Thus, now this is the left side, and now here the basic trigonometric identity sine square alpha plus cosine square alpha equals 1 comes to help. So instead of the first parentheses on the left, I replace it with 1. Now again, in this relation, if I square both sides, sine square alpha plus cosine square alpha to the power of 2 equals 1, what I get is sine to the power of 4 alpha plus 2 sine squares alpha cosine square alpha plus cosine to the power of 4 alpha equals 1. Now what I do here is replacing sine to the power of 4 alpha plus cosine to the power of 4 alpha with 1 minus 2 sine square alpha cosine square alpha. This shows that the left side equals 1 minus 3 sine square alpha cosine square alpha, and the identity is proven. Here is the next identity to prove. To start, I need a common denominator for the left side. Now, let's have a look at the right side of the relation. The numerator on the right side contains only cosine and the denominator contains only sine functions. So I replace sine in the left numerator with the equivalent cosine value, and the denominator with the equivalent sine value. Finally, by multiplying the numerator and denominator of the fraction on the left side by -1, both sides will be the same and the identity is proven. Now, the next identity to prove, first of all, I replace the cotangent function with its equivalent cosine over sine. Now, by multiplying by the conjugate, that second fraction on the left will turn into sine to the power of 4 over cosine to the power of 4. Now I need a common denominator, which is naturally cosine to the power of 4 theta. Now look at the numerator of the fraction. It reminds me of the difference of squares algebraic identity. So 1 minus sine to the power of 4 theta can be written as a squared minus b squared, which gives me two factors. Then, using the very basic trigonometric identity sine squared alpha plus cosine squared alpha equals 1, I replace one of the factors with its equivalent cosine squared alpha. Now I decompose the fraction into two fractions by replacing the second fraction with its equivalent tangent squared theta, and then inverting the tangent function, I will arrive at the right side of the identity. Now, to prove this identity, first consider the second fraction. To simplify this, we use the tangent identity. Tangent theta equals sine theta over cosine theta. Now a common denominator for numerator and the denominator of the same fraction. Now our identity becomes cosine theta plus sine theta over cosine theta minus sine theta plus cosine theta minus sine theta over cosine theta plus sine theta. Now we find another common denominator for these two fractions. Now simplify the numerator using the second and third algebraic identity. Notice that 2 sine alpha cosine alpha minus 2 sine alpha cosine alpha cancels out. Now I group the remaining terms: sine squared alpha plus cosine squared alpha plus sine squared alpha plus cosine squared alpha, each one equals 1, so it remains 2 on the numerator side. Now for the denominator, replace sine squared alpha with 1 minus cosine squared alpha using the Pythagorean identity. And it's proven. Now let's attack this identity where I use all of our famous tools. First of all, I replace the tangent function with its equivalent, sine over cosine. Then a common denominator, which is cosine to the power of 4 alpha here. Now I'm about to develop the numerator according to the famous identity difference of square. The right side parentheses of the numerator simply equals 1. Now I replace sine squared alpha with its equivalent, 1 minus cosine squared alpha. Now I decompose our fraction into two different fractions with the same denominator. Again, the same kind of exercises. I replace first of all the tangent function, and then I'm looking for a common denominator. And now, one more time, a very handy Pythagorean identity and replacing cosine squared alpha with 1 minus sine squared alpha. Now, as you can see, I'm very close to the right side of the relation. All I need to do is divide both the numerator and the denominator by cosine alpha, and the identity is proven. Now, here is a new type of exercise for this video. Given the value of sin x plus cosine x, we need to find the value of the product sin x by cosine x. Now look at this beautiful exercise. We know that in the second quadrant, sine of an angle oscillates between 1 and 0, so it has a positive value. And cosine of that same angle oscillates between 0 to -1. So it's got a negative value in this quadrant. And as you know, to handle potentially negative expressions inside absolute value signs, We need to multiply them by minus 1 to remove the absolute value.